In this video, we'll discuss the structure of atoms. Atoms consist of protons, neutrons, and electrons. Protons are positively charged, they're in the nucleus, and they have an atomic mass of 1. Neutrons are neutral, that means no charge. They're also located in the nucleus, and they also have an atomic mass of 1. Electrons are negative, they're located around the nucleus in a cloud, and they have an atomic mass of nearly 0.0005. And the ALEX, we will use this chart, so make sure you copy this in the notes. So you'll see different information on this chart that's missing, and sometimes it's really easy like this, name and symbol. And so what it's looking for here is the name and the symbol. You have to have the charge along with the letter for the symbol. And on all of these, you just provide the missing information. So now this time you see how it's charge. Now the tricky part about this question is this example right here. Notice that we have a P with a positive right there. That means it's a proton, right? Well, look at this next one. We have a positive 1 charge. So that means on this question, proton should be listed twice. And then we have negative, which means electron. So we're missing one. We're missing neutron. And if you come over here, you can see what I'm talking about. See proton, proton, and then electron. So don't fall for that trick. Atoms can either be neutral or have a charge. The charge could be positive or negative. Neutral atoms have the same number of protons and electrons, and we use the atomic number from the periodic table to determine the number of protons and electrons. If the atom does have a charge, we call that an ion. In this example, we're counting the protons and electrons in that neutral atom. So we come over here and find the periodic table. Hydrogen has an atomic number of 1. So that is 1 proton and 1 electron. 1 minus 1 is 0. Let's do another one. This time we have copper. So go to the periodic table, find copper. Cu, that's 29, atomic number 29. So that's 29 protons and 29 electrons. 29 and 29. Check. The electrons do exist on the outside of the atom, but they don't exist as orbiting like planets. It's more like a cloud of electrons where they spontaneously appear and disappear in different regions of space. And those regions of space are called orbitals. Now those orbitals can exist at different energy levels, and we can determine the number of energy levels of an atom by looking at the periodic table. If that atom is on the first period, it has 1 energy level. Second period would have 2 energy levels. Third period would have 3 energy levels. Fourth period would have 4, on and on and on. In this example, we will analyze atoms in terms of protons, electrons, valence electrons, and energy levels. But for now, let's just focus on the energy levels. So energy, electron shells, that's the same thing as an energy level. So if we look at oxygen, oxygen is in the second period, so it has 2 electron shells. So 2 electron shells. Selenium is in the fourth, right? There's selenium, fourth period, so it has 4 energy shells or electron shells. Sulfur is in the third, so guess what? 3. Valence electrons, so these are the electrons on the outer shell, and you can determine the number of valence electrons that an atom has by the group. So group 1 elements, they all have 1 valence electron. Group 2 elements all have 2. We skip the transition metals. Group 3 has 3, 4, 5, 6, 7, 8. Since we know that this atom is neutral, helium has, let's take a look. Look at this. Helium is in group 8A. Now this is the exception. Helium is the only, hydrogen and helium are the only two, since they're in the first energy level, they can only hold two valence electrons. So helium will have two valence electrons. Let's look at another one. Astatine. So we need to find astatine on the periodic table. So here's astatine. Look at what group this is. This is 7A. So 7A, that tells us there are 7 valence electrons. So now looking back at this example, with the symbol, you can take and look at the periodic table and find the number of protons, the number of electrons, the number of valence electrons, and then the energy shells. So protons, that's atomic number. Electrons, that's atomic number. Valence electrons is group number. Since this is group 1A, there's one valence electron. Number of electron shells, that's period. And that's how you do it.